quickie little background, because I'm going to guess that most of you most likely have never even heard of CableLabs. CableLabs has been around. This is our 30th year. We are the Bell Labs for the cable industry. We're headquartered here in Colorado. We have about 200 engineers now. We're approaching about 60 of those being PhDs. We do research from everything from next generation fiber optics to our largest research area, which is actually wireless. More than 50% of all U.S. homes have a CableLabs technology in the home. We're funded by 60 of the largest cable operators in the world. We're in 35 countries and 5 continents. On a worldwide basis, 500 million people use a CableLabs technology every day. So 200 engineers in little Louisville, Colorado. I took over in 2012 as the CEO there, and we've transformed CableLabs to be focused on innovations that are 3 to 8 years out. So what I'm going to share with you is what we refer to as the megatrends. These are the big things that are coming over the horizon from technologies and what the impact is going to be on businesses, personal, societal, government, what that impact is going to be on our lives. And in this case, we'll talk both on a business side, but also on a personal family side. What are these technology shifts and changes going to have on our lives? So what will the future look like? And working with the team at NewCloud, Sam, so I've just picked out some highlight technologies that we felt would be something of interest. So the first up, we're going to talk a little about cloud edge computing. What do we mean by cloud edge computing? NewCloud has its data centers, highly distributed. What you're seeing, though, is even at low latencies in the teens and 20 milliseconds, there's certain kinds of services that are coming that you've got to deliver 1.5, 2 millisecond total loop time back. So it doesn't, you can have the data center on the other side of town, you're not going to have 2 milliseconds. You literally have to be your compute being embedded right at what we call the edge. So 2018, we're seeing things like distributed data centers, like what NewCloud has, but we're also seeing other kinds of technologies that are coming in that are going to fuel this ability to take compute, put it down into really small packages, and literally put it right into like the neighborhood. FPGA and GPU acceleration as a service. More and more, if you're doing anything in artificial intelligence, we'll talk about that a little bit later, to take advantage of that, it's moving towards specialty chips, whether it's AI chipsets or FPGAs, or FPGAs, field programmable gate arrays. It's basically the cheater's version of creating custom silicon without having to go to fab. You can actually software encode a chip to make it look specialized. Or GPUs, the same GPUs your kids or grandkids or nieces and nephews use to play games. AI is using these chipsets, and if you're looking to get into AI and you don't want that huge capital cost, getting these available as a service becomes interesting. And then things like policy-driven infrastructure. It plays off a little bit of what we see as orchestrators today. You've got VM machines, knowing the rules around those VMs and how they operate, but this takes it all to a whole nother level. The one area that I spend actually a fairly decent amount of time in is in biological storage. Storage becomes the big constraining factor. If you look at, in the cable industry, how many different films are available for you on demand? If you have Comcast or Netflix, now take that to 4K, 4 times the size. Japan's about ready to launch 8K TV, right? So the amount of storage becomes a big constraining factor for us. 1 gram of DNA can store 1 billion terabytes. 1 gram of DNA can store 1 billion terabytes. An 8-ounce glass fluid of DNA can store every text, picture, image, video created by everybody in the world can be stored in an 8-ounce glass. And we have to manage all of our storage, right? Biological storage is going to be transformative to what businesses keep. Do you get rid of stuff? Do you have people delete? Do you just suck everything up like a vacuum cleaner? Hard part is now you got all this storage, how do you find anything? The other area that we're doing some research in that's interesting is intent-based networking. And intent-based networking is the network that adapts to the intent of its use. So it's actually watching how people are using the network, what is going across the network, and it self-adapts. It plays a big role in security. If it's seeing certain activities or certain issues occurring in the network, and you're all of a sudden doing something that the system views as the intent is doing something confidential or risky, set you off, put you into, to the intent of, think of it as a separate VLAN to run that completely separate so you're not commingled with anybody else. But it gets much more sophisticated even than just that. And there's a lot of interest in that. And then quantum computing. Google, Facebook, most universities now are doing work in some form of quantum computing. This being kind of the beyond silicon, the traditional silicon approach to making computing architectures. Very, very high performance. On the positive side, the negative side, quantum computing can break every piece of cryptography ever invented by man today. So quantum computing becomes prevalent and widely available. It doesn't matter what you have or how secure you think your data is, quantum computing instantly makes all that cryptography, in effect, meaningless. Let's talk about cybersecurity. Sam did a great introduction about the threats that we're seeing and the amount of attacks, denial of service attacks, and phishing, emails, and trying to, get access to credentials to get into systems. We see this all the time. At CableLabs, we have a research team. Our research team carries Department of Homeland Security clearance levels. We sit on the cyber threat floor in DC, so we see the attacks in real time because cable is the leading provider of broadband to consumers. So we take it really seriously because the way I explain it to our team and to the CEOs and the cable companies is cable brings the bad guys to the front door of consumers. And it's our role of how do we protect them. So we're doing a lot of work in AI-based cyber defense work, which is, you can try to do fingerprinting and profiling of cyber threats, but you're playing catch up, right? Because they're constantly adapting to how they're doing the attacks. You can't use traditional approaches. Crypto acceleration hardware is another area where it's happening because now, everybody's just encrypting everything or trying to encrypt as much as they possibly can. AI-based cyber offense, right? So how do you find something's happening before it happens? How do you turn into being predictive? It's actually interesting. You can actually see a series of weak signals occurring. So for instance, if you get a server that gets infected, one of the weak signals is you'll see the number of port attaches coming off that server that starts to inch up. Then we can take that server and restrict its ports outbound until we can do an analysis or completely segment that server off before it has a chance to even cause any damage. And just as we talked about quantum computing and its issues with cryptography, there's work that's doing quantum-resistant cryptography. Labs cryptography is probably the most prevalent that is out there today, so it's kind of, it's an interesting challenge. Early in my career, my background was in high-speed pattern recognition, and I was one of the founders of a company called ThumbScan, which is in the fingerprint biometric space. And our clients were all the three-letter agencies that we're all familiar with here. And what you quickly figure out when you're doing that kind of work is you build a better lock, and they build a better lockpick. Then you build a better lock, and they build a better lockpick. It's not a very satisfying career. It's like a never-done problem, right? So you're seeing all the guys working on quantum computing, which has huge ripple effects on any form of cryptography, any kind of private key authentication methods will be totally useless under quantum computing. Artificial intelligence, virtual digital assistants. We've all seen that. We've got open source AI platforms. We do a lot of work in AI. In fact, at CableLabs, I was successful in recruiting Dr. Bernard Huberman, who is head of AI research at Stanford, to now be full-time at CableLabs and running our AI research team. But with the availability of like TensorFlow and all the other open AI platforms, anybody can be playing around with some form of artificial intelligence today. It's pretty simple. And that's going to become more prevalent. Explainable AI is an area that I think is absolutely critical. If you believe, in fact, I was just at a conference, and one of the questions I got from the audience was where I came down on the whole issue of AI a friend or foe. Is it going to be a help for us, or is it going to wipe out mankind? Right? Elon Musk, he's on the wipe out mankind, end of it. You got a bunch of the companies in the valley. It's the greatest thing since sliced bread. What is it? And this gets into a whole conversation. I won't bore you with it here, but if you're interested, we can talk about it, about what I call ethical innovation. You can invent anything, but should you invent anything? And that's the question for innovators to think about. In the case of explainable AI, the problem with like machine learning is you're pumping a bunch of data in, and then you pump in to learn, and then you pump in the data and it tells you, is that a picture of a car? Is that a sunset? What is it? The hard part, though, is how do you explain how the decision was made? They can't really explain how it got to the decision, but it gives you a decision, which means depending on the training set or how the AI is programmed, you could inadvertently program bias into it. If you let the AI be turning into decision-making, you then have created a bias-based decision-making model. Explainable AI is a whole new area of research and science to say, how do you validate the decision to make sure you completely understand how that works, how the AI models such as machine learning, et cetera, came to its answer so that you can identify if there's any other bias issues in the decision making. This becomes more and more important as, for instance, governments are looking to use AI to improve decision making, even at governmental levels. Some of the other areas that are interesting is a lot of the edge AI. Rather than having big data centers, moving the AI closer to the user, and then you can use that AI for very rapid supportive decision making, very low latencies types of areas. Robotics. This is always a fun area. And we're seeing speech and voice recognition today with smart speakers, and they are working pretty well. Computer vision is pretty interesting. Facial recognition. Border and Customs Control has been using facial recognition to match people from their passport to their image, and they've caught their first guy who was coming in. He came in on a Brazilian passport, but he's actually from Africa. And the system flagged it. They pulled him aside. They did the search. They found his real IDs, which he'd stuck in his shoes. But the system worked. It realized that the picture, albeit looked really good, it looked like the person, was not the person coming through at border control. And you're going to see more and more of this. And this becomes interesting because companies that are leaders in this space, like Amazon, for example, is a big leader in facial recognition. They're in a big revolt with their employees. Their employees are signing petitions not to have their technologies made available to governments or to be used in bad ways. This gets back to the whole ethical innovation. Just because you can invent it, should you invent it? If you do invent it, who do you allow to use it? Google's having the same challenge. Google employees, like 10,000 employees, have signed a petition to get Google's AI research and stop all their work with the U.S. government as part of that. Some of the other area of robotics, cloud robotics is becoming an interesting point where you're doing remote robotics, and the robots is one location, but its decision making is in the cloud. And then Things like collaborative robots, robots working together to solve problems or to do certain actions or certain activities. So the question that all of this future generates is there's a lot of technology. And like I said, I just picked out 3 or 4 from our megatrends. Each one of those items is like a 10-page study report on robotic manipulation, or cloud robots, or collaborative robots. But what's really interesting for us is what is this going to mean for the changes to society as a whole? We talk about doom and gloom. AI is going to wipe out hundreds of thousands of jobs, right? If your job can be automated, AI can be applied to it, you're going to be out of a job, right? And there's been all this, doom and gloom and scaring and headlines in newspapers. And in fact, these new technologies create an entirely new class of jobs, right? And it's those people who can adapt to what those new jobs are. And as business owners, thinking about what are the jobs that I may not have today, but I should begin thinking about adding or thinking about what would happen as this future becomes a reality. So I just picked out 3. So if you step back and look at 2023, what are some jobs that could be created that don't exist today? These are not jobs that exist today. So the first one is person-machine workflow specialist, right? More and more is happening with machines, right? Whether it be IoT devices or smart buildings or whatever, right? So how do you become part of an expert in understanding how all those decisions are made and how you optimize those and how do you use collaborative robots to take on more tedious work? But you need someone to play the role to train that, to teach it, and to monitor that. Second one, AI ethics officer, right? AI by itself doesn't have good ethics or bad ethics. The ethics get defined by how the artificial intelligence gets applied. So be in the front line, ensuring that the company understands how trust, fairness, and justice should be evaluated and incorporated into future services and product lines powered by AI. We talk about this being a job in 2023. If you're going to use AI, and that AI is going to be customer-facing and decision-making, this is something you should be thinking about today. And be responsible for ensuring that the data sets used for training are bias-free. And that is a lot harder than it sounds, right? We have societal questions around what's biased and what's not biased, right? You may think, no, that's not biased. Somebody else looks at the exact same thing, and they'll think it's biased. So how do you define what bias is? And then metropolitan air and road traffic control. This is, given all of the unmanned air devices that are going to be out there, what are drones going to look like? You think about Manhattan, and if everybody that wanted to use drones to deliver products or services or to increase efficiency were all flying drones at the exact same time, the skies of New York would look like? It looked like the smog of London back in the 1800s with coal-powered plants. The sky would just literally be covered. How do you regulate that? How do you manage that? How do you monitor that? I've spent the last 25 years of my career has been focused on thinking about the future and where to target research and innovation efforts, whether that was when I was CTO at HP or whether I'm the CEO at CableLabs. So, but the real fact is most of us in this room, other than a couple of the new hires at New Cloud that just graduated, who I met, right? Most of us aren't going to be here when this future happens. It's going to be our kids and our grandkids who are going to be dealing with this future that we leave for them. So the question we have is how do we prepare the students of today to use a technology that's not yet been invented to solve problems we don't even know exist? The current educational model does not work in a high innovation rate society. The changes that we are having from the standpoint of the shift on innovation, it's accelerating, it's not slowing down. The challenge we have is we can think about the future, but the best thing that we can do in preparing for the future is for preparing our kids and our grandkids today. So they're the best equipped to take advantage of that. And there's this fundamental shift in the near future. We're shifting from an information economy, which most of us have grown up in and having very successful careers in, right? But it's about information and storage, and the learning model was we have access to all this information for better decision making, et cetera. But we're shifting to an innovation economy. The value that an employee brings to an organization in an innovation economy is about the quality of the ideas. It's that uniquely human ability to solve problems. It's that unique human ability to apply ingenuity. So at CableLabs, for the last 3 years, we've created what we call vision videos. Because we're 200 engineers. We can get our propellers going, and I can geek out with the best of them, and then the people who are interested, they're doing the doze off, right? The eyes glaze over. I got no idea what he's saying, right? And the hard part is how do we convey what these technologies are going to mean in people's lives? So the 2016 film was The Near Future, Bring It On. It was to address the question of what was home life going to be when you had access to all of these technologies in the home. Last year's film was also unique in the fact that we were fortunate enough to secure the support of playing one of the key roles in that film from Rance Howard, Ron Howard's dad. Rance was 86. Unfortunately, he passed away about 6 months after we wrapped the film. We were Rance's last project. He's been in 500 films. But he became very personally excited about what this future could really mean for it. What I'm going to show with you is this year's film. We just released it the first week of August at our event in Keystone, Colorado. This takes a look at what could the future of education look like. All the technologies that you're going to see in the film are technologies that we are working on at CableLabs. We are funding university research in those technologies, or we are partnering with third-party companies that are developed. We are co-innovating these technologies. So everything you see, this isn't a Buck Rogers film. That's the stuff that's going to be real.
Wow. My school's awesome. We're always doing cool stuff like this. Like, did you know that dragonflies have been around for 300 million years? I just learned that. Whoa. Us kids have minds like sponges. We're just waiting to soak up everything around us. We're naturally curious and love to dive in and figure out how things work. After all, it's what we're best at. A true sign of intelligence is not knowledge, but imagination. I didn't say that. Albert did. Follow me. Of course, you can't see imagination, but you can see what happens when it's let out. You can explore anywhere you want. It'll take you places you only ever dreamed of. And help you meet new people from all over the world.
Where do you live?
Like my best friend Alice. She's from Australia. I think it's pretty early there, so she's probably sleeping.
Sydney, Australia is 19 hours ahead of San Francisco, California. Local time is 5:30 a.m.
Thought so. Thanks, Dot. That was Dot, my AI assistant. We've all got one. They go everywhere with us, helping us learn and explore.
Hey, Millie. I know you're busy, but your history project on Madame Curie is due in 17 hours. I'll remind you again later.
Okay. I don't really know what I'd do without her. Where was I? Oh, yeah. Learning and exploring. Sometimes the answers aren't right there in front of you. You have to dig a little. Look at things in different ways. Because there's usually more than one way to solve a problem.
Oh, wow. He's a lot of Yeah, it's some like over there.
And guess what? There will always be problems to be solved. Luckily, we're really good at that. My teacher, Mrs. Garcia, says it's good to take everything at your own speed. And don't be afraid to get things wrong once in a while. After all, mistakes are proof that you're trying. She says sometimes it just takes a little time before it all makes sense. I feel that way when it comes to math. But I am getting better though. I've still got loads to learn and ways to go because it takes a long time to get educated. Oh, that's cool. But I know that one day I'll be here, working, maybe even in a place like this. I don't really know what I want to be when I grow up. Perhaps that job doesn't even exist yet. Mrs. Garcia says that learning never really stops because life never stops teaching. That works for me because I'll never want to stop learning. I mean, why would you? No one knows what the world will really look like when I grow up. Definitely something more amazing than we've even got now. No matter what though, I know that when it's my turn to help make the world work, I'll be ready.
Hey, Millie.
Hi, Mom.
Hi, sweetie. How was school today?
Awesome. Did you know that dragonflies have been around for 300 million years?
Wow, I guess you learn something new every day.
I know.
If you want to view the film again, it's available on YouTube. It's also available on CableLabs and also the 2 previous years. I don't typically like to string them together because they're like 3.5, 4 minutes each, and it makes for a pretty long one. But it's our view. We're not developing all of those technologies. That's not the role of CableLabs. We're building the network that those innovations will run on top of. We believe that the network that we're building is the best platform to innovate on top of. And we use these films as an inspiration in order to inspire innovators, in order for them to think about what would be possible at some point in the future. So some of the technologies you saw Millie when she was looking at the dragonfly. It's a little subtle, but when she takes the glasses off and the kids who she's who's engaged with, who's part of her science team, they kind of fade away. They're not in the same classroom. They're from all over the world, all coming together to have that one experience. And that's what we call distance VR. And distance VR does require edge compute. To get that latency down, keep it very tight so it feels like you're having side-by-side interactions, you need to have that. The whole video wall where you saw the kids throwing colors on it or asking questions about Mars, that's 2 classrooms over distance looking like they're literally looking at each other through a pane of glass. But it's actually 2 displays that are fully interactive. Mixed reality, so this is a combination of VR with, in this case, a science experiment. If I have zero gravity and I drop a bowling ball and a feather, which is going to hit the ground, right? They hit the ground at the same time. This allows them to experience it, not just read about it in a book. IoT is pretty prevalent. You're seeing a lot of what we call low-power networks being deployed. In fact, CableLabs, we operate a low-rate network throughout northern Colorado. As part of our test, the FCC grants us experimental licenses. So we have one that actually goes from Cherry Creek south all the way to the Wyoming border. And we use that in partnership with some government agencies for weather reporting and weather stations along the Front Range. But you're going to see that just become natural. It's happening today. I mean, anybody here have a Nest thermostat in their house, or Nest smoke detectors, or Yale digital locks, or Ring doorbells, the video cameras in it? We're there today. Light field table and light field holodecks. This is using a new kinds of display technology. Today, the largest light field display is about 2 feet by 2 feet. But it actually projects at a very high resolution, full 3D volumetric. You can literally walk around both sides of the display and you will see it as a volume. You'll see whatever's being projected on the display, and you can interact in it in 3D, allowing students to experiment. And so nowadays, it's no longer about having to have a full science lab. You can literally let them experiment, see everything, without needing it for real. Silicon Valley, up until a couple of years ago, I was on the board of directors for the Tech, which is the Innovation Museum in Silicon Valley. It's funded by Bill Hewlett and David Packard, so HP is very involved in it. Interestingly enough, though, a couple of years ago, we had to install wet labs at the Tech. Why? Because high schools in Silicon Valley no longer have wet labs. You couldn't do a biology experiment in a science classroom in Silicon Valley. So the Tech actually built out the entire labs, and that teachers then would bring their students to the museum in order to experiment, because you can read about it, but when you can actually do it and see it, that's what transforms education. The light field holodeck, where you saw the floor in the back panel, that is work as part of some of the collaboration. The first two people from the right that you saw in were local. The two people from the left are projected in. They have their own holodeck in their office, so they're there in person and they see everybody else projected into the space. So this is, for all intents and purposes, the equivalent of the holodeck that we've all seen in science fiction. Today, on a 2-foot by 2-foot light field display, and you want to have two objects on both sides where it can be manipulated so you feel like you're both in the same room, requires about 800 megabits of sustained symmetrical speed. So if you think about putting that into students' homes, let them do experiments, think about how big the network is going to need to get. There's a thing in the broadband industry we call Nielsen's Law. It projects what the speed of the network is going to need to be. And so today, Nielsen's Law is predicting 1 gigabit services to consumers. What you may not realize is that 60% of all US homes now have the ability to buy a 1 gig service from your cable provider. 60%. Colorado, you're golden, right? That 2016, that was 4% of homes throughout the US. You look at 2024, 2025, that 1 gig becomes 10 gig to consumers' homes. So with that, I'm going to wrap up.